So now I'm going to talk about bead-based sample cleanups. So many protocols use these magnetic beads. They're known as Ampure or SPRI beads. And what they do is they allow you to clean up DNA without binding to a column. These can all be done in the same tubes that you're preparing your samples in. And you use a magnetic stand to help move those beads to the side instead of using a centrifuge. And these beads take advantage of the fact that nucleic acids can be precipitated by polyethylene glycol, a polymer, and salt. And again, some of the advantages here is that it doesn't require a column or centrifuge to do the cleanup, and so it's really amenable to working with multi-channel pipettes or even liquid handlers that can handle 96 or 384 samples at a time. And the other advantage is that by adjusting concentration of salt and polyethylene glycol, you can actually isolate specific sizes of nucleic acid, which has advantages. And this is based off some principles that were discovered in the 70s, where some researchers realized that if you alter the concentration of PEG, also known as polyethylene glycol, you can precipitate different size fragments of DNA. So if you start off with DNA with a wide size range, going from 100 bases all the way up to about 50,000 bases, if you have a high concentration of PEG, you can precipitate most of that DNA. And as you drop the PEG concentration, you notice that you're precipitating only the larger fragments of DNA. And these authors realized that this could be used to take advantage, you could take advantage of this property to isolate specific fragments of DNA. So in this example, instead of doing a few separate reactions, what they did was they started with a sample of DNA that has a large size range. They added 6% PEG, took everything that precipitated from there, and then took the supernatant that had the smaller fragments, moved that over to a new tube, added a little bit more PEG to bump up the concentration to then 6.5%, took the things that precipitated and took the supernatant and added some more. And doing the stepwise process, you can see that they're able to isolate specific ranges of DNA. And this is really handy for next generation sequencing library prep, because a lot of times we really want to isolate DNA of a certain size range. And this is a very easy way of doing this, because you don't have to deal with any gels, cutting fragments out of gels, extracting them. This is all happening kind of in solution, and it's very, very useful. So this method still depended on centrifugation because you had to spin down and precipitate DNA at the bottom of the tube. But in the 90s, a newer method using magnetic beads, but also with these PEG and sodium chloride solutions came about. And essentially it works this way. You have a sample that you want to isolate nucleic acids from. You add your bead solution that contains these magnetic beads and PEG and salt. You mix it and let it sit for a few minutes. And this causes the nucleic acids to precipitate on the surface of these magnetic beads. You place the tube on a magnet, the beads with the nucleic acid get bound and then moved to the side. And you can remove the supernatant and do a couple of washes. And then at the end, you can elute the DNA off of the beads just in water. And that'll cause the DNA to come off of the beads. You put it back on the magnets, and then you take the supernatant that now contains your eluted nucleic acids, and then you can move them into a new tube and then either go on to sequencing or the next step of your sample preparation. And again, all of this doesn't require any tubes or doesn't require any columns or centrifuges.